Now, in this video, I will explain the implementation of 8-bit up-down counter using Verilog HDL in Vivado tool. So in previous lecture, I already explained how to create a new project. It means source file, design source, constraint file, simulation source and everything. New project is already created. Now you need to add a design source, create a file, create a new source file and add it to your project. Give the file name, your project name is the counter. So I'm providing the name as counter. Just clicked on finish. Now here is asking you just keep the model name. So counter is okay. You can add input output port definitions. Input whatever you are taking and output. So here input I want to have clock. Clock has one of the input, then reset followed by mode, and if you want you can add some more. Now here I am adding the output. Output is the Y and here MSB. Write down 7 down to 0. And just clicked OK. Now look at here in this project manager window, like there is the sources. In design source you can click on the counter. So double clicked on it, counter.v file. You can see here there is the Verilog program. So you already given the project name counter and module name counter. So look at here line number 23, it's written module counter. Whatever you did, the setup for the input and output that you can see over here. So our input is clock, reset and mode. Now here mode select up or down followed by the output. Since here modeling is the behavior model, set the output to which already registered. Then define the statement for the counter. Behavior modeling always start with the @ positive age of clock. That's why here written POSC post POS EDGA and clock CLK. Begin followed by end. Then check the condition for reset. If reset equal to 1, then Y is equal to 0. This is the procedural assignment statement. Now write down the else. Then go to mode selection. If mode equal to 1, then Y is equal to Y plus 1. That means this is a up counter. This statement performs the up counting. This is a procedural non-blocking assignment statement. Else you can write Y is less than equal to Y minus 1. That is the start down counting. Once the design is completed, you can check the 0 errors, 0 warning and 0 notes. Look at this green color symbol. Then save the design. If you want, you can remove this. Again, save the design. And If you want, elaborate the design. So look at here in RTL analysis, just click on the open elaborated design. Here it will take few seconds. So once the design is elaborated, this is the behavior modeling of a 8-bit counter with the RTL schematic. You can note all of these parameters. Once the design is completed, go to Run Simulation to verify the design. Here again it will take few seconds. So here 8 counter counts from 0 to 225 maximum. Maximum value. Enlarge this window. You can see here waveform. Here, if you want to see the result, first what you want to do, you can just click on the clock, right click and look at here force clock. Click on this force clock. Now here write down leading edge value 1, else 0 whatever, but first starting with the 1 and then trailing edge value you can write down the 0. And no need to change of the value radix is hexadecimal. Sometimes they will ask the binary, but we will start with the hexa. Now no need to change period of the cycle. Here it's mentioned 100 nanosecond, so it is fine. Now they clicked on the OK. Now I want to provide the reset signal to 1 so that counter is at 0. For that use force constant. Here force constant force value is enabled as 1 so that the counter stays set as the 1. Then click OK. Now look at here, clicked on run or you can decrease the time period. Just do 1000 nanosecond. See that the counter value is 0 when reset is equal to 1. Change the reset and move. Again right clicked on the force constant. Here change the reset to 0 and mode to 1. Now the counter start up count. Run for another 1000 nanosecond. As soon as the mode is 1, the counter started counting the values or incrementing the values. Since I have simulated for only 1000 nanosecond, so it is giving 9. Again another 1000 nanosecond, it gives you the more values. So the total count goes up to 0 to 255. You can increment step by step. And one more thing, if you want, you can change the mode. Same, right click or radix of this unsigned decimal. Increment the value so it goes on. Up to 255 it goes on counting. Now I want the mode to 0. Force constant, make the value to 0. Because of the 0 value, the counter start down count. Now clicked on run for another 1000 nanosecond. Try to observe the change. You can change color as well. Here change for 0, it counted maximum to 60, then started decrementing towards 1. Again you run, so it is down counting the counter. It goes on. Now you can see how the counter is decrement. If you want, you can change the style, waveform style to analog. And see that the value is being decremented. Also, you can set the color to yellow. See that the yellow color is decrementing gradually. And for up counter, count the value is incremented. So for each and every value it is being incremented. So this is how 8-bit counter is implemented using a Verilog HDL in Vivado.